Hey guys, this is Milo, the Pug engineer. Do you want to learn Swift in less than 45 minutes and then build a password generator app using Xcode? Today, we are going to do exactly that. Alright, in today's video, we are going to go through the basics of Swift and then we are going to build a very simple application, a password generator. Swift is an amazing language, easy to understand, but also can become quite complex. In this tutorial, do not expect to be a Swift guru in just 45 minutes. You will need to work way more for that. But after the video, you will have enough to deep dive by yourself. Without further ado, let's fire up Xcode and get started. Create a new playground. And I will start with variables. And in Swift, you can declare variables with let. It's an immutable variable, which means that it cannot be changed. Some other languages call it a constant. So for example, we can say let message equals welcome. And I will set my playground to run automatically. And you can see welcome. And if now I will try to change it, for example, message equals pug, it will give me an error because it's a let, it cannot be changed. If you want to declare a variable that can be changed, then you should use var instead. Equals pug engineer. And then you can change it by simply assigning another value to it. All right. You can declare multiple variables in a single line. For example, var, a number, and another number. If you don't want to declare a value, you can declare the type. Those two will be integers. To cast a variable into a different type, you can do it like that. For example, let's declare a variable. And we can use the type that we want to cast it, and then the variable name, and we'll cast it in this case as an integer. All right, Swift has tuples, and you declare a tuple by entering the values of the tuple into the parentheses, such as this, and then you can reference the values by using .0, which it will reference the first value here, or .1, which it will reference the second value. You can also use named tuples, and we can use, for example, status code 400 message bad request, and then we can reference a named tuple by using either message or the status code. Let's talk about checking type. And to do that, we have to use the is keyword. So first, let's declare some empty classes. So I will declare a dog class, and then a class pug, which inherits from dog, and then a class cogger, which inherits from dog. Then I will create an array which contains a pug and a cogger, and I need parentheses in those. So to check the first element of the array, what kind of dog is, I can do if dogs array dot first, which is the first object, is pug print. This is a pug. All right, and we'll print it down there. So is keyword is used to check the type of a class or the type of a struct. We can also use the as keyword in combination with if let, and we can say, for example, if let pug equals dogs array dot first as pug print first element is pug, else print first element is not a pug. And in this case, there is an error that because we are not using the variable pug, so inside the print command, you can put a backslash and then parentheses and then the variable name, and we'll print it. All right, pug. Now, if I switch the objects here, for example, the first is a cocker and the second is a pug, then the if let clause, it will fall into the else and it will execute this piece of code. And this is how you're checking the type of an object. There is a way in Swift to force downcast objects or variables. And let's do an example. And I will declare that variable with any type, which means it can be anything, or string, or an integer, an object, whatever. Milo, and another one. My age, any, and this is an integer, and an array. And I will put those variables in the array. And now to force downcast, we can say let, for example, first item equals an array dot first as string. But we have to put the exclamation mark here that will cause Swift to force downcast it. This array contains 2 elements of any type. So it means Swift doesn't really know what type is that and will try to cast it as a string. And if it succeeds, it's all good. But there's also a case that that may fail and it will cause the application to crash. For example, if my name is, for example, a float, it will crash the application. You can also do an implicit downcast by using the question mark. For example, let last item equals an array dot last as int. And it will execute that piece of code. It will try to cast it as an int. And if it succeeds, you will have an integer in the last item. But if it's not an integer, then it will output nil. For example, if I have a string here, this last item variable will be nil. We can declare variables as optionals. For example, optional string, and then we will say string with question mark equals punk engineer. And if we try to print that out, it will give us an optional string in the output. All right, you can see it is marked as optional. And if you want to check if that string is nil or not, then you can use if let optional string equals optional string and then open curly brackets, optional string. And this will try to assign the optional string into itself and it will output it as not optional. But if it fails, you can also say else optional string is nil. So for example, now if we try to have a nil here or don't assign anything, then it will run this piece of code because optional string is nil. And if you want to force downcast it, you can also do that. Let's put a variable again here. And you can do, for example, optional string exclamation mark. But again, if you force something, then if that is nil, it will cause a crash. So let's talk about guard. It is another way to unwrap optionals like if let. Guard in many cases can lead to cleaner, more readable code, and it's a bit hard to understand its value now and why use it over if let, but if you start programming more complex applications in Swift, it will become cleaner when guard is suitable to be used. So let's give an example. I will create 3 variables first. String equals a string. Let a float equals, let's say 54.21. Let a dog, and that's a dog class, equals dog. Okay, and all those are optionals, okay? And now I will create a function So func guard example. And in here, we can say guard let a string equals a string, let a float equals a float, let a dog equals a dog, else. All right, and what it will happen here, it will try to unwrap all those. And if it fails, it will run whatever is in the else context. So print didn't pass. And you have to return from here, but you can also continue, break, or throw if you want. That's an option. And let's go down here and say print a string, a float, dog. Okay, what it will happen here, it will try to unwrap all those variables. If it succeeds, it will go here, and you can use those variables from now on after the guard statement. If it fails, it will execute this piece of code, and then it will exit the function. All right? So now if we call guard example, we will see the string, the float, and the dog class down here. But if something is nil, let's say the float, it will run this piece of code here. And then it will exit. It will never run whatever is after the guard. Okay? You can also have checks in the guard. For example, you can say a float bigger than 40, and in this case it's 54, so it will actually pass the guard. But if you don't meet that condition, it will fail the guard and will exit the scope. Okay? That's pretty powerful. It can lead to cleaner code most of the times, not every time, but in most cases, you can use guard over let and the code will look cleaner. Let's talk a bit about defer, which is used to execute code before exiting the scope. And it's helpful if you want to do cleanup before leaving the scope. So let's do an example again. I will have a var here called another float, equals 35, 32, whatever. And I will create a function. Okay, and in here I will print maybe something. And then I will set that another float to a different value. And then I will print something else, another float. Okay, and I will run this function. And yeah, there's an error here. Okay, another float is 100. And another float, it remains 100 after that function run. So let's say you want to reset that float before you exit the function. So the simplest way to do this is actually use defer. And you can call defer in any place inside the function. So you can say defer another float equals 35, 32. So what it will happen now, it will run this piece. And once it's about to exit the scope of the function, it will go into the defer and will run this. So the float in this case, it will be 100. But once it exits, the float will go back to 35.32 as it is here. Okay, and that's defer, how it's used. One of the useful cases that you can use defer is with combination with guard. And let's give an example on that. Guard example. And I will set again another float to 100. And I will copy what we have here. And I will add print another float. Okay, and let's run this guard example. And then actually also see what happens to another float. And we already have a guard example, so I will rename that to another guard example. Okay, now what it will happen, it will unwrap those variables and will output them here. At the same time, it will set that float to 100 and it will print the float. And when you see another float is 100, guard didn't pass. One of the cases to use defer is if guard fails for some reason, you want to do some cleanup. So let's say if guard didn't pass, we can use defer and set another float back to its initial value. Okay, so what happens is we set the float to 100. Then it will try to run the guard, but it will fail because a float is above 40. So it will print this statement, then it will return. So we are exiting the guard scope. So defer will run in this case and will execute this piece here. So it will reset another float to 35, 32. And you can see it here. Guard didn't pass. If guard succeed, Then another float will be 100. It will try to run the guard statement. It will succeed. So nothing in here will run. It will continue and it will print this. And after that, it will print another float, which is still 100. So is that clear? This is how defer works. And you can also have multiple defers. And those will run in reverse order. What it means is first, this defer will run, and after that, this one will run. Okay, and that's all about defer. Okay, let's work a bit with functions now. So we can say func, say hello, parentheses, and then curly brackets. And inside here, we can execute anything we want. So I will put just a hello. And then we can call that function by just saying hello, say hello parentheses, and we'll output it here. We can have, of course, arguments in the function. So we can say func, say hello to person, and we will have a string here. So person will be a string, and let's try printing hello, and then / parentheses person. Then we can say hello to Moby, right? Hello, Moby. Functions can return something back. So for example, I create a sum function which sums A and B, which they are two integers, and returns an integer. And I can simply say return A plus B, and I will call it. And you can see the output right here. Also, functions can have default values. So for example, function, and let's say greet person, which is a string, and the default person will be Milo. And we'll say print hello and person. And we can call this function by simply calling greet without passing any value. And it will use the default value in that argument, which is Milo. It will say hello, Milo. But we can also pass something, greet person Moby, and it will use that argument value instead. All right, hello, Moby. Functions in Swift can have variadic parameters, which means an infinite amount of arguments. And I will give an example of that. Func, let's say sum all. And we want an infinite amount of ints to pass as arguments. And this is marked by the 3 dots in here. And we would like to return an int again. And we can do sum equals 0 or number in numbers, sum plus equals number, and finally return sum. There are other ways to do this, but this is simple enough to understand. And then we can say sum all, and we can pass a simple variable, just one value here. Oops, I have an error. Numbers. Okay, and we can say 1, but I can also pass 2 or 5 or as many as I want, and will give me the sum. So those are variadic parameters, and you can define them with the 3 dots. If you want to modify the argument you are passing inside the function, you can use the in-out keyword, and let's create a function called modify, and I will pass a string, and we need to pass this specific argument is an in-out argument, and that it can be modified, and then output a string from that function. And inside here, we can say, for example, string plus equals, and will be the initial value with a modification, return string. And to call it, we need to first create a var, let's say Milo argument, and call it Milo, and then call that function and pass that argument, that var argument, with an ampersand character in front. And it will give us Milo with a modification. Because it went into the function, it modified that initial argument string, and it output the same string. Let's talk about error handling. I will first create an enumeration, and we can do that by specifying enum and then calculate error. And that's an error type. And we can say case sum is 0 and case sum is 100. All right, and that's an enum. And then we can say, let's create a function. Calculate a int, b int, and instead of directly returning a value, this time we will say throws int. And that means this function can throw an error. So we can now say if a plus b equals 100, throw calculate error and sum is 100. Or we can say if a plus b equals 0, throw calculate error, sum is 0. Otherwise, return a plus b. Then we do, and we can say let sum, and we need to use the keyword try, and then calculate, and we need lowercase, which is a function. And we will say 10, and let's say 20 here, and print success. And then I will put that sum variable here. And if that fails with an error, cuts calculate error dot sum is 100, or cuts calculate error sum is 0 and print it. Okay, so do, and then it will try to execute this piece with the try keyword. If it succeeds, it will continue. Otherwise, if an error is thrown, it will jump over here, and depends on the error, it will output either this or this. So for the moment, it's outputting success equals 30. But if my arguments are 0, it will jump to the error and say error sum is 0. Or if the sum is 100, it will jump into the first case here, sum is 100, and it will throw that. And this is how error handling works in Swift. Let's talk a bit more about enums. So we can declare enums as we did over here, but there is also another way. We can say enum dog breed, for example, and we can have a single line declaring all the enums we want. Okay, and that's a way to declare enum. And then if we want to use that enum in a variable, we can say dog breed, and that's a dog breed type, and equals dot, for example, pug. And if I type dot here, it will output the choices we have in that enum. So pug. We can use the enums with Swift if you want. Switch. So switch dog breed, and not the enum, but the variable dog breed. And say case pug, print that's a pug, or case cocker, print cocker. And we can also say if none of those two, default, print, let's say unknown breed. Okay, and this will give us that's a pug. We can also have values assigned to enums, and I will create a new enum, and that will be a float. All right, and in here I can say case short, and I will assign a value, or medium, or long. Okay, that enum over here now has float values assigned to it, and we can again specify a variable the same way as before, and we can access either the enum itself, which in this case it will be short, all right, short, or the row value, which it will be the float we assigned next to it, 0.1, 0.1. That's super useful. In Swift, Structs has a lot of power in compared to other languages. For example, they can have initializers, they can have functions, they can be extended, and they can conform to protocols. But also structs can do everything classes can do. For example, they do not have inheritance. So let's give some examples. So I will create a class teacher, and I will have a name here, string, and I will assign a value to it. And then I will have a struct principal, and I will give a name again. And let's give that struct a function. All right, and here is a struct with a function. All right. One difference between them is classes are reference type, while structures and enumerations are value types. A value type is a type those values is copied when it's assigned to a variable or a constant, or when it is passed to a function. And to understand that, let's create an instance of a teacher and another teacher, and assign the second teacher the first teacher. In this case, t should be lowercase. So we have an instance of a teacher, and then we created another instance and we assigned the first teacher on the second instance. So if you see now the values stored in those classes, it's Milo the Pug and Milo the Pug Engineer. Same value. All right. Now, if I try to change the first instance name to something else, and if I try to explore again the second instance, what happened? You will see also that the second instance inherited the first instance value. All right, so whatever you change on one instance, it will change on the other. Structs, on the other hand, they will not do that. They will copy the value. So let's create a struct and another one, and again assign the first principal to the second struct. And we can see here, the first one is Moby the Cocker Spaniel principal. The second one is Moby the Cocker Spaniel principal. And I will change the first principal's name. And I will print out the second principal also. So the first principal in this case should be Jane Doe. The second principal is John Doe, as we initially assigned it. So the value is copied. All right. We talked already a bit before about subclassing, but let's give another example. In this case, I will say class undergraduate student and number of missing classes equals 3. And we can override a function of the class by having the override keyword. And in this case, we are going to override the full name. So we can say override full name, and let's print undergraduate student and pass the name, the surname, and let's say missing classes, and just add here the number of missing classes. All right. This is a way to create a subclass and then override a function inside the subclass. You can also extend classes in Swift, and we can use extension student. And by extending classes, I mean we can have new functions or computed properties. So let's create a computed property in this case. Let's say, for example, name with title, and that's a string. And we can say return doctor name. Okay. Or let's create a new function in the student class, say hello, and we need also parentheses, and then say print. And in print, we can reference the original class variables. So in this case, we will use just the computed property above. So name with title is saying hello. Okay. And then we can say student, or we have already a Milo student. We can say hello. And it will override this, and it will say Dr. Milo is saying hello. So protocols in Swift, they are like blueprints of method properties, and other classes may call them interfaces. And I will give an example how you create a protocol. So protocols, and we just have to put the protocol keyword before protocol. And let's create a loan protocol, and let's have a variable amount, which will be an int, and you can just get the variable or set, but in this case, we will just get that variable, and then a function loan amount. And now let's create a class that inherits that protocol. Class student on depth. And that should be loan, not load, on depth. All right. And it's a student class, but also inherits the loan protocol. And if I leave that empty, it will give me an error that does not conform to protocol loan. That means it doesn't include that function and that variable. And I will define that now. So for example, let amount equals 10,000. And then let's have the function loan amount and just print name with title is owning amount. All right. And now it will conform and will also have those required functions and variables. And to call it, we can say student depth name, Milo, surname, the pug, grades. Let's have the grades here and just call loan amount. And will give us Dr. Milo is owning 10,000. All right, that's all for this episode. In the second part, we are going to continue with closures, collections, dictionaries, and higher order functions. And at the end, we are going to build an app. Oh, and don't forget to like and subscribe. See you in part 2.